All right, we're live now, and we welcome everyone who's interested and who's joined this Hangout on Air, which is mainly about major 21st century disruptive technologies and their adoption, present adoption, and likely future scenarios for businesses. I'm Raja Mitra, and I'm one of the co-founders of Digital CRM, which is the organization founded in Singapore, basically into consulting and consulting activities in the arena of social media, cloud computing, analytics, big data, and so on. So we are both into consulting activities as well as training and workshops and seminars in these areas for corporates. So those are our primary activities. I will let I think some of the people are beginning to come in now, so I'll let them do a brief introduction. As far as introducing myself is concerned, I have engineering, and I did a post-graduation in management from IIT and IIM in India, and I've been working in the arena of IT and telecom for a long time, virtually all my career. And I've been into hardware and software services, the whole gamut, and across various regions. I've worked for some time in India, and I've been based out of Singapore for a long time, and that's where Digital CRM is incorporated. This is like a new startup that we did about a couple years back, and we are into some of these areas that we are going to be that I just mentioned. So saying that, I'll maybe request Vikas, who's with us, to give a brief introduction to the audience here, and then maybe Subhamoy and Indrani, whom I see has joined, and we can introduce ourselves, and we'll get going from there.
Sure. Thanks, Raja, for that introduction. So I'm Vikas Kadadi. I've about 13 years of experience in the industry, mostly into the technology part of it. I've been consulting for a while, and now doing something similar as well, more into the development and the delivery management. More on my education, I am from IIT Guwahati, computer science, and I've been working in Bangalore for a while in a company named Trilogy, and moved to US in 2006, and been working in Minneapolis, Minnesota ever since. So I joined Raja's session today just to get an understanding about what the latest technologies in the CRM are. And of course, I'm attracted to the buzzwords like big data and machine learning, as everyone is. And that's why I'm here.
All right. Thanks, Vikas. Maybe Subhamoy, you can take on next, and then after that, Indrani, you can introduce yourself briefly.
Sure. So thanks, Raja. I am into IT for almost last 12 years or so. By education, I am an engineer. I did my graduation from Yadavpur and masters in computer science from ISI. And I have been working with multiple companies like Cognizant, Oracle, Wipro, and like that. I worked in mobile devices for a long time, into product development for a long time. And right now I am involved with a finance company where I am working on their IT strategy and getting into things like rolling out enterprise mobility, cloud, and all these things. So I'm also attracted to this discussion because of the new things that we'll be talking about. I'll be sharing some of the ideas that I may contribute to some extent. So looking forward to a good discussion.
Yeah, Indrani, would you like to briefly introduce yourself to the audience, whoever is in here? And we were expecting some more people, but they aren't here. But I see some people are in the viewing mode, maybe on the YouTube link. But nevertheless, just give an introduction, and we'll get going.
I have a master's in life science. I am currently working on a research program in ISI, but basically I'm a homemaker who's very much intrigued by new technology and I hope to learn something from this session today.
Okay, yeah, I think that about introduces all the people here. Let me just kick off this session by giving an overview of some of the stuff that we had in mind, and I hope you can see the title slide. Is that visible?
Yes, it's
It is visible, right? Okay.
Uh,
So,
Raja, we can't see your slide. Can you check once?
oh, it's not visible. Okay. Sure. Just give me a minute. Okay. Um, yeah. This should be okay, right?
Yes, that's right.
Okay. So yeah, that's the title of the hangout on air that we planned for today. And as you can see the subtitles, we are planning to talk about areas like artificial intelligence, neural networks, machine learning, deep learning, smart search, Internet of Things, predictive analytics and big data, and we'll then go on to talking about their adoption by businesses and what are the possibilities and how could these disruptive technologies and these very major developments be used by 21st century businesses. So okay, we had actually artificial intelligence has been in one form or the other been around for a long time. I mean, for quite some time, but it's lately gained a lot of impetus because of several developments. And it's to give a quick definition of artificial intelligence, it is where systems progressively learn based on their experience, based on certain data and repetitive data and information that they keep on feeding on, and as a result of which they get smarter. Uh, it's a huge area, and so I'll instead of going into too many details, let me talk about, for example, neural networks and about deep learning. Now, neural networks are basically, the name comes from it's derived from the neurons, which the human brain has. And neural networks are supposed to closely simulate, in a very simplistic fashion, the human brain neurons. Now, the neurons in the human brain are they're an extremely complicated structure, we're not going to go into that because we are not specialists into that as well. But today's neural networks actually organize there are several layers of artificial neurons which can be trained, or which, like I was mentioning, do train themselves after a while to essentially figure out a coherent pattern and a coherent data from a whole host of what I'd call very randomized inputs, in the structured inputs, unstructured inputs, and so on. In some ways, it is very similar, analogous to if you visualize a child learning from various random inputs, which pours into his or her virgin senses, and that's how a child learns. Now, it's a very similar way, in a far more simplistic fashion, that neural networks train themselves over a period of time. Now, these are expected to usher in what is referred to as the age of intelligent computer systems, which learn on the job and progressively get smarter and more powerful. So as they go along, as they get into more data, they learn more and they become smarter as a result. And this is an ongoing process, which is again similar to the learning process of a human being over a period of time. So just to give an example, like for example, search. Search is one such application where search over a period of time becomes smarter. And it finally develops into what people call a prosthetic brain or an extension of the human brain. And it is supposed to get into a situation where it is able to anticipate a lot of your needs or what exactly you may be looking for or deciding to act on at a period of time. So that's like personalized search getting smarter. A few other examples of deep learning is, for example, if you feed large volumes of emails into a deep learning system and start labeling them as, say, very simplistically, let's say, as spam and non-spam, just two labels. And over a period of time, the deep learning system is supposed to intuit based on all that unstructured, complex content which is contained in these emails, and figure out for itself what is spam and what is non-spam, and then initiate action that you may ask it to initiate. For example, put the spam into a spam folder. So that's one example. Google, for example, is heavily into deep learning systems. They've got some of the best people there, and one of the projects where they have been fairly successful so far was in identifying objects from images, and therefore be able to caption photos. Now, without being told, I mean, there are several examples which you can look up later, but without being told about what the object is, it has, for example, studied a huge volume of images over a period of time, and then it is actually able to figure out, for example, saying that this is a tree and this may be a tiger and this may be a car, and look at, for example, a particular sequence and actually give textual captions like saying a car driving along a road or stuff like that, a cat climbing a tree or stuff like that. So which is, it is able to do itself without being told specifically about this being a tree and this being a cat and so on. Google did one of a project on YouTube videos over a long period of time, and the deep learning systems were able to identify cats. Because there are a whole lot of cat videos which are there on YouTube, so they were able to identify cats after a period of time without being told that they are cats. Okay. Some of the other applications, I mean, I'm just giving random examples here. Some of the other applications could be in like instant, near real-time language translation engines. For example, if you over a period of time, if you train it and you utter, say, a series of distinct words, for example, in English, and you're looking for, say, a translation into German. So at the end of a string of words or a sequence of words, you need to send it a kind of marker saying end of English language, for example. And then the system would, in real time, start spewing out the German translation as soon as you end the English language sentence or paragraph or whatever it is that you want translated. There are, Google is into a lot of exotic projects. They have a lab called Project X, which is highly secretive, confidential, and there are a lot of projects which are going on there. Some of the projects which had come out of there were Google Glass and the self-driving car and so on. Now they have a project called Project Calico, which is supposed to be extending human lifespan, and it uses deep learning techniques. I do not know too many other details. Some of the other envisaged areas are like deep learning systems which can learn complex computer games, of course, deep learning has also been utilized in self-driving cars and in robotics as well. So that's an overview of neural networks, deep learning, and I will possibly request Subhamoy to take us on to maybe some of the other areas like the Internet of Things and search and smart search and so on. Hi, Debashish.
Hi, Xavier. Finally
Okay.
able to join.
Yeah. Yeah, Debashish, we just started off because we were time, and I've just covered. Uh,
I was watching you actually.
okay, yeah, Debashish, should you? I mean, I covered very briefly the area of artificial intelligence, but since you are here, and maybe you could briefly introduce yourself to the audience, whoever is viewing and whoever is in the room, and maybe expound on artificial intelligence in some more detail before we carry on further.
Uh, yes, I'm Devashish Guho. I am an engineer originally by training from Kharagpur, like Raja. Later, I went on to do a PhD in operations research, and I have been working in the general area of statistical learning and predictive modeling for quite some time, mostly in the financial area. Um, I saw part of what Raja has described in terms of artificial intelligence. I will, instead of going deeper into that, I will give you a little bit of introduction into what we mean by the word, the phrase machine learning. Here, machine, of course, means thinking machines, in other words, computers. And in many ways, machine learning is just another word for, or another phrase for statistical learning. And in most of big data, predictive analytics, data analytics, most of it is a restatement of statistical methodology, but adapted towards uh, large data sets. And the use of large data sets necessitates certain computational techniques that are new, but in terms of what statistical techniques are used, they are really quite old and go back more than 100 years in many cases. Now, machine learning or statistical learning, what is it what does it mean really? I have a uh, very crude uh, write up, PowerPoint presentation that I'm going to show you if I can. If I can do this, share. Uh, Apparently, I don't know how to do this. So I'm going to stay out of that. Okay, I'm just going to continue. Machine learning is a method of learning structure and patterns from data, which is usually cross-sectional or time series. That means it's data that has been collected over time and often contains data on various features of the system. And what we are trying to learn is the the relationship between the input and the output. That is, there is a black box of some sort which takes certain inputs and provides a certain output. Uh, and we do not know what is inside the box because it's black. So we need to study the input and the output and try to figure out what is going on within the box so that first we understand what the box is doing and also we can build a new box that can take new inputs and produce similar outputs. I'll give you an example, a very common and widely used example. And this is the marketing function. There is a website, let us say, where people come in and it's some sort of e-commerce website and they look at various items that are displayed on this website and they either buy or they leave the website without buying. So the input may be various features of the people that have access to websites. This may include uh, anything that is known about them, say where they are coming from, at what time they have visited the website, where they came from, that is to say how they found the site. Uh, they may be asked to input certain data, in which case you know more about it, their gender, their ethnic background, their nationality, and so on. You may or may not know some of this. And also their tracking pattern, what parts of the website they saw, and how they navigated the website. This is the input. And then the output, of course, is what they bought, if anything. You don't, and what is the black box? The black box is what goes on in their mind, presumably, that leads to them either buying something or leaving without buying anything. So this is the machine learning task of studying a large number of input vectors and the corresponding output vector and trying to figure out what goes on that combines those inputs in order to find the output. And this is, there are various technologies that go into, and the classical one, of course, is what is called regression, which is to estimate a function known only from its inputs and outputs, and you have to define certain parameters of the function. The simplest assumption is that it's a linear function. There could be other assumptions that the function lies in certain mathematical spaces. They have certain smoothness properties. They have certain local smoothness properties. These go into technical issues. And there are really two major ways to classify this the learning function. One is supervised learning. Supervised learning means that we are trying to learn a function where we observe the input and we observe the output that has come in the past. To give you another example, credit scoring is a classical learning function. You discern certain properties of the creditor, his name, his address, where he lives, his age, his sex, his past financial behavior, and so on. Based on that, you want to find out whether he is likely to default on a loan. And then you have a database of people whose features are known and who have either defaulted or not defaulted on their loan. And that then you try to define a function. It usually is given in terms of a score. That score tells you whether they're how likely, the higher the score, less likely they are to default on a loan. So this is another version of machine learning. There may be other machine learning problems which are mechanical problems. Learning the behavior of the human eye, for instance, machine vision. That is a learning problem. Self-driving cars is a learning problem, one that has become very useful recently. These cars actually learn from driving. Another well-known learning problem is problem of voice-activated commands, Siri in iPhone. Uh, it learns the speech patterns and the accent of the owner who is issuing these commands, and over time learns to recognize the individual speech patterns and habits of the person issuing the commands and responding to these commands. This is another learning function, and again it can be thought of as a input-output mapping function learning problem. There are many other such problems, and all of them can be considered machine learning, and most of artificial intelligence can be recast as a machine learning problem. Because let's say a classical artificial intelligence problem is problem of constructing robots that can walk. And walking is a very difficult problem for, especially in an environment where there are obstacles. So learning to walk inside a room where there is furniture and not bump into those furniture. That is the classical AI problem, and it is again a machine learning problem because Often this is a neural network design problem, and you take feedback from actually bumping into things, and slowly the robot learns the layout of the furniture in the room and learns how not to bump into things. That's a rough guide to what machine learning is, and much of big data analytics is actually machine learning. For instance, predictive analytics. What is predictive analytics? It is nothing but a form of machine learning. That is to say, again, you learn various features, often of customers or of, one of the classic predictive analytics problems is that of fraud detection. You look at credit card transactions and certain features of this transaction. For instance, who is initiating it, what is the amount of the transaction, what is the location of the transaction, what is the amount, what is the purchase item, and so on. And based on these inputs, you try to classify whether the uh, the transaction may be fraudulent or not. So it's a classification problem, or it can be a probability type of problem where you uh, try to assess what is the risk of that the transaction might be fraudulent. Again, this is a predictive analytics problem and a machine learning problem. Many of these problems, the other set of machine learning problems is the so-called unsupervised learning problem. This is an exploratory problem where you don't know really what the output is. You want to learn some features of the problem. For instance, clustering. For instance, let's say that you are selling something. You want to learn what is the pattern of people who are buying this. What defines your target population? You may not have anything in mind in terms of what you are looking for, but you want to learn over time how to cluster your target population into groups so that you can target them better. That's the other major type of machine learning problem. With this, I'm going to turn this back to Raja and continue in other directions.
Yeah. Okay. Yeah. Thanks, Devashi, for I think that's a fairly good overview of what machine learning is all about, and some ideas about predictive analytics. I was talking about, for example, smart search, or what in certain cases is known as semantic search, and I'll not dwell on it too long because that itself is a long process. Uh, Semantic, as you know, is basically search where you are using English language as an input. It could be English language, questions which are framed in as a simple English language query, or it could even be, as Debashis was mentioned, voice input, which is then kind of the machine learns about it and translates it into the query, and then there are a whole lot of data points, and it works on a huge big data set, and
Hey,
tries and kind of pulls out the exact kind of answers. So I'll not get into too many of details on that. It's another, like I was saying, I gave a few examples. Maybe we can quickly go on to the Internet of Things, which Subhamoy, you could maybe cover that, and
Sure. So, can you see my screen?
Not
Raja, can
really.
yeah, yeah, Subhamoy, are you on?
you see my screen, Raja?
Yes, I can.
Okay. So thanks everyone once again. What we'll do is we'll cover Internet of Things to some extent. Uh, there will be four things that we'll cover within IoT. I mean, IoT is a vast topic and it has many dynamics, many disciplines involved in it. So we'll start with start with what is IoT part, and then we'll talk about how big the IoT market can become in the near future. We'll also talk a bit about the design considerations within IoT, and then pick up a case study and talk about some of the stuff there. So to start with, we'll talk about what is IoT. I mean, IoT has been a pretty popular term these days, and there are many buzzwords also around that. Many corporations have been using many keywords to define IoT. One of them is smart planet, or some of the corporations talking about system of systems. So, what is it? I mean, is it only connected homes and cities? Is it only connected cars and roads? Or is it only about some sensors that is getting embedded within us? That's a popular kind of definition. We'll also talk about the computer scientist definition. So when we ask a computer scientist that what is IoT, he will possibly say that it's a network of physical objects which has an IP address with it and may or may not have a unique ID. So to put it in plain English, that's like having some objects with you, things like mobile phone or things like sensors within your refrigerator or some other electronic gadgets, and then making them talk to each other. So that's a pretty high level idea about what is IoT. The second piece that we'll talk about is how big is that market going to be. Now, if you can see my slide, there are few quotes, few numbers from Cisco, Intel, IDC, and Gartner, and they are talking very big numbers. I mean, it's in billions and trillions by 2020. I will not get into the specific numbers there, but if you look at it practically, right now, everyone in the Hangout possibly will have two devices connected to them. That's a mobile phone or a tablet or pad kind of thing. But fast forward by 5 years or 10 years, possibly we'll have many more connected to you. Like there will be smart doors where you can open the door with a smartphone, or things like Fitbit are already there in the market, pretty popular. You will have mobile connected lighting. I mean, you can switch on or switch off or reduce or increase the illumination of the light. You will have smart heaters, you will have smart refrigerators, you will have smart AC, you will have smart toaster. So now look at it this way, that right now you have two smart devices with you, and it gets multiplied by so many times. So now if you look at it that way, possibly the numbers that are predicted by Cisco or Intel or people like Gartner, that will be justified. So there is a huge possibility the market is really big, and it will be a sea of devices that will be engulfing us. So the next topic that we'll pick up is a little technical. So what we'll say is, how does it look like if I look at the topology of a IoT design? So we split it in three different parts. The first part is a sensor. I mean, things like, say, a health sensor which gets embedded within a Fitbit device, or something like a heartbeat monitor, which can be a light sensor. Then the next bit is these sensors connect to some aggregators, which can be a router or which can be a smart device, through which these devices or sensors push the data to a remote cloud-based processing center. So now the question is, are we doing the computing within the sensors, or are we pushing the computing to the cloud devices? That's a design thing, so we'll not get into much details on that. But some of the considerations is to make the sensors pretty energy efficient, because you think of it this way, that if you have a Fitbit stripped with you, or if you have a medical sensor stripped with you, it has to work 24/7. So it has to be pretty energy efficient, otherwise you will be running out of battery very frequently. Also, they have to last longer. So if you think of a mobile phone, generally nowadays a mobile phone doesn't last beyond 1.5 years or 2 years. We keep on changing the smartphones almost every year or so. But if you look at your refrigerator, possibly that goes for more than 5 years, or possibly 4 and 5 years. So the reliability factor of an IoT device should be much longer than a smartphone device. And the other point that we talk about is cost effectiveness. So if you have two costly devices like smartphone like devices, that will not work out. So we need to think of fabrication technology where we can put MCU, and we have a lesser costly devices which can make IoT much more popular. The last point that I would like to discuss about is the data handling. That's very important because
One
IoT,
question.
yes, sure.
Can you please repeat the last point of yours? I didn't follow that. If you could please repeat yourself.
I was talking about the MCU part, like the devices that we need to use as IoT sensor devices. They
Yeah,
need to be pretty cost effective. So if you put CPU and you make it heavy, then possibly that may not work out. So what we are talking about is microcontroller unit driven devices, which can take the info there. Possibly they will not store the info at those endpoints, but push those info to the cloud devices. So instead of doing the computing at the endpoint, we are pushing the computing to the backend,
I see.
which makes many things. I mean, which makes the energy efficiency high, which reduces the cost, and which possibly also increases the reliability. So that's the strategy generally people are taking. So
I,
that's also the first point on the right side, computing point, whether you want a dumb terminal or a smart terminal.
I see. So you are plumbing all the data into the cloud and then you are computing it at only one node rather than the edges, is what you're saying.
That's one approach. I mean, I don't say that that's the only approach. So if you look at Fitbit, what they do is they store the data temporarily in the device, and once you connect to your PC or your smartphone, then they push the data back to the server. So in that case, the computing is happening in cloud, but the
Right.
aggregation of data temporarily is happening in the local store. So finally, it's going to cloud. You are doing all the analytics there, and there lies the first point, which is the security part of it. So when you are pushing the data over wire or wireless medium, there is a lot of security concerns there, because here we are talking about health data. Here we are talking about very significant data which is close to us. So I will move to the next slide, which talks about some of these. So if you have used, any of you have used Fitbit or something like those devices, you'll know that you can figure out how many miles you have walked, or even it can figure out whether your sleep quality was good or not. Now, think of a situation where somebody is able to hack into your device, or somebody is able to tap into the data that's moving from your Fitbit device to the cloud, and getting all this data. Like he can figure out where do you live, what is your health statistics, when did you go for a vacation, and things like that. So that becomes pretty serious, because these are all personal data. So how do you protect that is an important point. So Symantec did a long analysis on that, and it came out that almost 20% of the devices actually send the data on plain text, which is like not acceptable at all. So if you are designing an IoT device, if you are designing IoT topology, then first thing is how do you protect the data at at the device as well as over the air. So there are many things around. I will not get into much details on that, but the main point that we are trying to drive here is, since these IoT devices are very much embedded within our life, the security part is a very serious point, and we need to keep that in mind when we are designing those devices as well as when we are using those devices. So one typical concern that people raise is about when I lost the device. For example, I may have misplaced the Fitbit device. Will somebody start using that, or will there be a secondary authentication that, okay, so you are the same guy who was using it half an hour back? So those kind of things needs to be kept in mind when you are designing these things. I will possibly close the session here from my end, and if there are any points that Raja or anybody wants to add, we can keep it open here.
Yeah, just a query here, or maybe I'll reserve that for the end of this session. What I do is, since Debashish covered predictive analytics, and we were actually expecting Eli here, and I was thinking of kind of asking him to touch on big data. But since he's not here, and I think predictive analytics, is fairly analogous to goes on to big data. So maybe Devashish can, expound on that for very briefly, and then we can take any questions or discussions on whatever we have discussed, and then move on to the next subtopic, which is like applications and in the business arena and how these are being deployed currently.
All right. Can everybody hear me?
Yeah, just a feedback, just a couple of observations. One is, Vikas and Devashish, is it possible to have your cameras on, if possible?
Yeah. I've turned it off. Okay.
Okay, no, because I think, and because for you also, I think the camera is off. It will be good if you can.
Can you see me?
Yeah, give me like a couple of minutes here, please.
Sure, sure. No, take your time. I just thought I'd give you that feedback. The second is, not very sure, but from one of the participants, there's some amount of background noise coming in terms of some in the street noises or maybe household noises. I'm not very able, but kind of that is interfering. So is it possible to either cut it out or maybe mute your mic when you're not speaking, so that that noise is cut out?
Yeah. Well, it may be mine because there is a lot of noise around me. But
Yeah, I'm not sure which one. Then I have to do an exercise of muting individually, which I haven't. But just an observation. So having said that, yeah, we can move on to you talking about big data and how it is, and how it kind of dovetails into predictive analytics and so on.
yeah. Well, big data, as I'm sure all of you know, is the big buzzword these days. Big data is big business and big hype. And some people say that it is merely another word for statistics. Some people say that it's something new, and sometimes it's called data science, sometimes it's called data analytics. The what is it really? Well, first of all, it is what it just says it is. It is large size databases. When we say large, we mean peta or exabyte size databases. Uh, and we have had gigabyte size databases for a long time now, and terabyte size is fairly common these days, and petabyte is not that uncommon, and the next step is going to be exabyte. What this means is that these databases, the traditional methods of database manipulation are not going to work. This is a big data, the science of big data, if you will, has two parts to it. One is the statistics part, and the other is the computer science part. Part of it is simply the question of how you handle, in terms of software and hardware, these size databases. Obviously, you cannot load it all into memory, so you have to keep it on some kind of server farm and just pick out the parts that actually are needed at any one time. Also, this data is probably not going to be able to be handled by a single processor. So you need some kind of array of processors, and so therefore there has to be a methodology where the data resides on a server farm, and the process and it cycles through the processor, and it somehow is put together. The analysis is put together somehow using software. So there is this whole software issue and a hardware issue of actually how to access the data. And traditional methods of simply loading it onto RAM and sending queries to it will not work. The big player in this is what is Hadoop, which is a Google invention. It is kind of getting obsolete obsolete at this point, and new technologies are coming in, and it's a very fast-moving field where I'm not really an expert and I can't tell you what the latest state of the art is. Uh, there is another aspect to it, and that is the statistical aspect. How to actually handle classical procedures like regression or classification or dimensional reduction on very large databases, and also how to organize these databases, because the traditional method of database is a matrix, really, you know, the table. The table method again will fail in this case because the size is too big. So you need other forms of data organization. Also, many of these databases have very large dimensionality. That is to say that data is being collected automatically on a very large number of features of the uh, input variable. So when for instance the NSA collects data on phone calls, uh, we're talking about a very large number of features that they're looking for. Uh, this is a database that consists of all phone calls made between points um, in US controlled phones to any two US controlled phones. And you know, you have obviously location and so on, but also you have various keywords that they're looking for in terms of, you know, identifying criminal or other activity. And soon you're talking about very large number of dimensions, but large number of features that you're tracking. There is also the question of, for instance, another classic use is text mining. You look at, let's say, Twitter. You look at, you know, billions of pieces of Twitter tweets. All of these have, these are natural language tweets. Let us say just English ones. So then any English language sentence, and that's all it is because it's short, it's a tweet, has a large semantic featured landscape. So the number of dimensions on which you have to project this data is very large, and that's just one sentence. And obviously different people are talking about different things, and therefore the number of dimensions is getting larger and larger. So now we are talking about a data set in which the number of data points is comparable to or perhaps less than the number of features that we are looking for. Obviously, in a statistical sense, this is an ill-posed problem, and you cannot really handle it. But some methods have now been proposed to reduce the dimensionality of the problem and focus in on features that really matter and so on. But this is again very much a field in transition, and you need to look at it. Uh, every day things are changing. So then that's one aspect of big data that is in very rapid flux. There are certain other aspects that are becoming more standard. For instance, association mining of large data sets. Then, you know, large-scale response mining, where, you know, the thing that I talked about, for instance, in e-commerce websites, let's say in Amazon or something like that, you have very large number of people who are visiting this website, and they're looking at books or other you know, items, other merchandise, and then making a decision of what to buy and what not to buy. And there may be, for instance, one possibility that is now being just getting into is uh, if you go to a supermarket, then there may be targeted sales for specific individuals. You have some kind of an identifier, a frequent shopper card or something like that, that you swipe or it is somehow detected. So the server knows who you are, and it knows your buying pattern, and it knows at what price point you are likely to buy something. and then there is a sale that is only for you, and your price is different from. So when you pick up uh, a bag of fruit or something like that, and you wait, then the price that it flashes is not the same for you as it would be for me, because you are maybe a favored customer, or by analyzing the data of your past purchases, the algorithm has determined that there is a certain price point where you're likely to buy. So again, this is again a big data crunching problem, because you have a large number of customers, their shopping habits, the price points at which they're likely to buy things, and then you tailor it to their particular buying habits. There are many such things that are being tried out. Another major piece of big data is coming out of the biggest piece of big data actually is not business at all. The largest data set actually comes from astronomy. And astronomy, as you might know, is actually the birthplace of statistics. Gauss himself was, of course, an astronomer, and the least squares problem that Gauss first solved was to calculate planetary orbits from observational data. Even today, a very large amount of cosmological data is downloaded from telescopes and radio telescopes, and that's a very large data crunching problem and a big data problem. Another major big data source is climatological data that is collected, and that has to do with the whole question of warming, global warming. And this is again a big data crunching problem. So science itself, various scientific fields have very large big data crunching uh, issues, and very major amount of effort is being directed towards that end. Then another major data crunching problem comes from the market, financial market, especially high frequency trading, where you have tick by tick data of large number of assets collected over large number of exchanges and other trading sites across the world, and that needs to be crunched, and trading decisions need to be made. That is another big data problem. Uh, Obviously, website data from large websites such as Google are well known. Search data, Google stores everything. We all know that, and they're mainly used for targeting ads. Facebook, for instance, Facebook bought WhatsApp for what, 22 million or something, billion, I mean, sorry. Uh, and WhatsApp doesn't have any revenue. It has no ads. It doesn't cost anything. So why did they pay for this? And one theory is that they paid it for the data. That WhatsApp collects all your data of what you have put into it, and that tells Facebook what ads to direct your way. Again, this data crunching problem. A lot of it is text mining. Text mining gets to be even bigger than numerical mining, and that is all some of the uses of big data that we see. Back to
The
you, Raja.
strange, the interesting part with WhatsApp was how did they figure out the economics of making it free across all the platforms across all the mobile platforms? I
Yes, it's
guess.
not clear how they're going to make any money. Supposedly they're going to charge $1 a year. Uh, Even at $1 a year, they're not making much money.
Oh, I
Not
see.
nothing close to justifying the price tag that they have. So there's a lot of speculation as to why Facebook paid that large figure. And one
I,
theory is that they're paying for the data.
Yeah, if
I
I may just add to that, particularly about WhatsApp, I think Facebook were fairly prescient in visualizing the explosion in terms of number of users, and therefore, of course, the data and the user base that is going to happen in the area of messaging. Now, interestingly, if you look at Facebook's, I think when they picked up WhatsApp, it was like maybe about 25 million or 30 million users. It now talks about close to 700 million monthly active users, which is the metrics typically used by these to describe the number of active users. And interestingly, most of this growth has happened in outside the United States. One of the biggest markets for WhatsApp outside the US is India. And I don't have specific data on this, but I can only surmise that one of the reasons is because various reasons, but one of the reasons is that SMS comparatively in India, I think, is still quote unquote expensive. SMS is not free. It is not something that comes along as part of your package and so on. And which is why once kind of people got 2G and 3G data even on their smartphones or tablets, they started communicating through WhatsApp. And of course, then there are the additional features of WhatsApp like group messaging and the other features which are being added on now. Video is just being added on. So I think once they have gotten to these numbers, as Debashi said, the revenue model, the business model is not yet clear because WhatsApp per se as a division or whatever within Facebook is not making any money. But one will have to wait and see, because I suppose at these numbers now, very soon, the business model will become clearer. Okay, so I think we have roughly covered the areas that we had mentioned, and at this stage, maybe we could have, if there are any questions or clarifications, including from those who are viewing. If there are any questions, please key in your questions, because we can see your questions here in this Hangout, and we can take up them for answering. Or if there are any questions from the participants, we can take that on before moving on to applications in businesses of some of these technology that we have been talking about.
Oh, I found this very interesting and very enriching. And from a life science point of view, I feel that artificial intelligence research will help in neuroscience research also, which is a very good thing. Um, that's the least one can say. And this is very educative for me, very useful, especially because I conduct soft skill quizzes for engineering students. So learning from here can help me to give them inputs that they relate to. So thank you so much, and I would like to say bye now. Thank you again, Rajada, for inviting
All right,
me.
we haven't we are not at the end of the session. We are continuing, but if you want to kind of drop off for any other personal schedules, I mean, please do. But the session will continue for some more time.
Okay, if I can, I'll join in again. Thank you so much.
All right. Okay.
Raja, we talked about WhatsApp. So one pretty popular topic is security of WhatsApp. You want to discuss on that?
Sorry, can you say that again?
The security on WhatsApp. You want to talk about that, because that's quite close to your heart.
All right. No, I think we've had this discussion off and on over some time now, because most of these messaging apps, the user privacy or security was not well taken care of. If you see WhatsApp, for example, and several other apps like these kinds, the user ID is actually your phone number. And then I think your password is actually your IMEI number, IMEI, and so on. So how secure is this data with WhatsApp, which they're collecting? And there have been several complaints in the past which say that the WhatsApp app actually goes and lifts your entire contacts database. Now, of course, I think over a period of time, possibly those have been plugged because, particularly now that it is a part of Facebook, and Facebook has issues data privacy and user data security. But still, the fact that you have phone numbers, which for example, in many a case people would like to keep private and secure, are the user ID is a matter of concern for many of these messaging applications, apps. Which is why if you see, for example, Google Hangout, uses your profile or your Google ID to let you communicate, and of course there's a talk function. You can do a phone and so on, but that is optional. But the normal Hangout does not bring into play your phone numbers and so on. But anyway, that's just a observation, because that does not seem to have hindered either. None of these concerns seem to have hindered the growth of Facebook or the growth of messaging communications. In addition to WhatsApp, which is very popular in India, and in people have experienced tremendous amount of growth. Then there's Line and so on. So messaging apps are big time. They are. That's where the numbers are growing at a very very fast clip. So that's the other observation I have. Uh, okay, just
one,
getting back to a query mode. Subhamoy, while talking about IoT, possibly one of the hindrances in the growth and development of IoT is that while there's this huge amount of data which is being generated, and this huge number of sensors and devices which are supposed to be generating these over the next several years. Um, Many of these are not entirely. I mean, there are no standards as yet. So, if there are certain open system standards and so on, which become the governing standards for most IoT devices. Because today you have many IoT devices which have closed standards, and they're operating within their own realm and within their own domain, and they are not very transparent or open to other IoT devices. So I think there's some kind of a standardization which needs to emerge over there sooner rather than later. What would you say to that?
Yeah, I mean that's right. So as we said that IoT is a conglomeration of multiple disciplines. So it will evolve possibly on the device side, on the data side, on the communication technology side. It will evolve. Even we are talking about things like the usage of spectrum will go pretty high if you look at all these devices talking to each other. So the technology through which devices are talking to each other may also be changed so that the payload size gets reduced and you have a better communication. So a lot of things needs to be done yet on that.
so just one quick question. When we say IoT, is it just the interaction between these billions of devices? Is that what we're referring to that, or anything more than interaction?
So IoT people define it many ways. I mean, people talk about like machine-to-machine communication, machine-to-infrastructure communication, machine-to-human communication. So you look at it this way that you have a smartphone with you, possibly you will have 10 more devices with you, and you want to remotely communicate between them, or they are pulling some data and sending that data to some remote control center. So, for example, if you have a sensor which is taking data from the bed of the ocean, so it will take the data and feed that data to the backend system. It's again a remote controlling system. Or we talk about traffic system. So we talk about smart cities. Possibly Raja can talk about that in a little more detail. But a smart traffic system, what it will do is it will see if there is an accident, for example, on the way, and then it loops back that data back to the control center, which can feed into a digital display that says ahead of the accident that wait a second, there is a accident ahead, so take an exit and move into a different way. So all these things again is part of IoT. I mean, possibly those signals, those traffic signals will become smarter, and those traffic signals create a network amongst them. Within cities, that can be a case. So, for example, if there is an accident, we talked about taking an exit road for the next vehicle. We can also connect to the airport, which may think that there are a lot of traffic getting stuck on this road. So, do we change the schedule? So, IoT is a big thing. I mean, we really can't say that it's only machine to machine. It's more than that.
I see.
Yeah. Okay. Just to add to that, I think the prime usage of all this huge volume of data which IoT, the Internet of Things, is supposed to generate, because these are sensors which could be generating bits of data every few seconds or every minute or whatever, depending on the frequency that you put them at. And their usage is going to be finally in the area of predictive analytics or big data, or for example in the case of smart cities, where you'll be pulling in all that data and then kind of trying to project or trying to locate maybe certain problem area, or a certain pattern and so on. Because just to we will of course, we are planning to schedule another session specifically on big data and predictive analytics soon, within maybe possibly the next month or so, so we can talk a lot more in detail about some of these aspects. But just to give a very quick overview, see, big data is conceptually, it's not about, see, if you look at smaller data sets, and typically the approach so far has been that you look at smaller data sets and you have a certain hypothesis, and you have very exact data, and you have a sample which is a smaller data set, and you, based on that hypothesis, you analyze that data, you slice dice that data, and do whatever to arrive at certain conclusions. Or now big data is does not look at causation, it looks at correlation. So it'll tell you that if you look at a whole lot of parameters and a huge volume of data, and on a whole lot of parameters over a period of time, it'll tell you where the strong correlations are, and where the weak correlations are, depending on if you know the right questions to ask, or or the right, if you define the problem correctly. Now it'll not tell you causes. For example, it will not tell you that. We will get into that a little more in detail when we talk about some applications. But the thinking there is that typically from a business point of view, there may not be a need to know causes. I'll give you a very typical, very classical example of big data, because Walmart, for example, in the US, did a big data analysis of a whole lot of data that they have been capturing across all their retail outlets and over the years and so on. And very interestingly, it was found that when there is a major hurricane or storm warning, of course, there are certain devices, certain appliances, and like torches or hurricane lanterns and stuff like that, whose sales go up when in the region where such a warning is issued. But what they also found, interestingly, and which other than big data analysis may not have been found, was that at the same time, the sales of Pop Tarts also went up significantly. Now this was a strong correlation found. Now if you ask somebody what's the cause of it, why do hurricane warnings in certain regions trigger higher sales of Pop Tarts? It doesn't tell you that. It will not tell you that. So the causation is not known or unclear in a lot of big data analysis. But it doesn't matter for Walmart, because what happens is that once they found this strong correlation, what they started doing was, the moment there was a storm warning or a hurricane warning in a particular region, in addition to stocking the usual devices whose sales go up during such a warning, they also started stocking and displaying very large volumes of Pop Tarts, maybe just outside the door or just inside the door and so on, because now they knew that those become hot selling items when such a warning is done. So that's just one example of how big data tells you correlations, but it is not based on a preset hypothesis, or it is not based on, it does not tell you anything about causation. So, or causality, if I may put it that way. So that's one distinction I wanted to make.
So one question there, and when you say big data, it's all about infrastructure, right? It's not about it's all the tools that Cloudera offers. That's what is big data. But you still have to write the algorithms on top of it to make the correlations work, or create that model, right?
Yeah, I mean, see, it's very complex, and today I think actual implementation of big data analytics is restricted to very few large corporations, and and maybe it's happening inside the Googles and the Facebooks and the Microsofts and the IBMs or the Apples, and but beyond that and beyond a few large corporations. I haven't come across too many examples of real implementation of big data.
Correct.
That is one of the reasons is, like as Debashish was saying, that for example, today there are how Hadoop is really the open system version of what Google evolved,
Map.
called MapReduce.
Yeah.
And then MapReduce was taken, and then Yahoo came up with Hadoop. Now, I think even I have come across people who work in big data and who don't understand Hadoop per se. They may have undergone a training here and a training there, but they don't understand Hadoop per se. So, if I may give a example, Hadoop is maybe at a lower level, but there are a lot of analysis tools which sit on top of Hadoop, and people are actually kind of deciding which of these tools to use, and after churning the data through using Hadoop or whatever, to derive at that to arrive at certain these kind of correlations or whatever patterns that one
Right.
is talking about. But
Right.
the issue is that I think in most cases, unless you have experienced people, you have people who have a very strong statistical or data science background and so on. People are often, classical MIS, for example, is or even the concerned manager or the departmental manager is not quite able to define the problem in most cases. What is the problem, or what is the end objective that doing all that big data analysis is going to achieve. So in very many cases the objective itself is not clear, because like for example, some of us were discussing some time back, in most cases you will see in organizations people arrive at predetermined conclusions. People arrive at a preset hypothesis and saying, all right, this is happening. For example, you'll say that, look, during monsoons in India, for example, the sales of certain drugs go up. So that's a hypothesis that they work on, and then they get to reinforce that hypothesis and they work on that. But the big data approach is often very different. It says that look, do away with your what I might call preconceived notions.
Right.
Do not be biased or prejudiced, if I may put it that way, by any kind of preconceived notion about what is causing what. So do not start with causality, but just look at all the possible parameters. Just look at data. It doesn't matter whether that data is exact data or not, because a lot of big data is messy data. It can be very messy data. It can be textual data. It can be unstructured data. It's high volume data. So there are a whole lot of things there. But so basically, when you start with that kind of a premise, the problem or what you want to arrive at is often very difficult to define for both functional managers as well as maybe internal MI. Internal MIS people anyway don't define the problem. It has to be the functional manager or the top management which needs to define a problem or needs to define what they're looking at.
Right.
So
Right.
those are some of the issues today, I think, with big data analytics.
Sure.
Raja,
Sure.
if I may add to that, first off, let us not forget that causal analysis is, even in classical statistics, small data is a very difficult problem. Correlation is easy to measure. Causation is much more difficult to measure.
I see.
It is a very active area of research, and a lot of work has been done recently by Julio Corral and people like him. But it is far from being settled, and it is constantly in flux. So in most cases, uh, even with small data, you wouldn't really attempt uh, to identify causal factors, only correlation, or something like correlation. Uh, Secondly, the question of suppose you have a classical problem of regression.
Yeah.
What is it that we are assuming there? We are assuming that we know the set of inputs and we know the set of outputs. That is, we know the input variables and we know the output variables. What is unknown is the map that takes the input to the output. In practical settings, this is often not the case, especially with regard to the input. Let's think about it. Let's say that I want to predict what the price of the S&P 500 is going to be a month from now. It's a classical stock market forecasting problem. Do we know what the inputs are? By no means. What goes into defining or determining stock prices? Nobody really knows that. Or take another classical forecasting problem. The question of someone, a visitor to an e-commerce site, what makes him buy something rather than nothing, or one thing rather than some other thing? You really don't know. You have no clue. Most people have not studied this. Even people who have studied it in detail, like people at Amazon or Google or places like that, you don't really know what the input variables are. In some
Right.
cases, like the case the very famous case of Pop Tarts that you cited, you don't know what the output variables might be. In other words, it's an unsupervised learning problem. You try to learn what happens when some event has taken place, and you don't know what all might happen. So therefore, the output set is also unknown. Um, these problems, it's not that these were never discussed in classical statistics, but the methodology wasn't really available uh, to handle these problems, and
Right.
there was no need really to work on it. Like statisticians or any other scientists, they only work on problems that make some sense. And applied scientists work on problems which somebody is willing to pay for. And Google is willing to pay for this knowledge, and they
Right.
hired Hal Varian, and he is working on this. So the question is, once there is a large amount of data, much of it unstructured, then there is a question of, can we even think of solving these issues, or can we even think of posing such problems? And like the question came up, you still have to decide on some kind of a model. But these models may be slightly different from straight regression models. Because in regression, as I said, by default, you're assuming that you know the set of inputs and the set of outputs. There are problems where there are feature selection regression where you start with a large number of input variables and you weed out some of them. So there is some classical statistics work on this, but this work has exploded recently in terms of how you approach these kinds
Which
of
one?
problems in terms of
Can you
formulation.
please repeat, Debasish, which one has exploded? You were talking about regression. What was the other
Yeah,
model that
yeah,
is?
regression with very high dimensionality regression,
Okay.
where you don't even know whether certain dimensions are important or not. You start
Got it.
with a very large number of features, possible features. Say you want to predict whether somebody will buy something. Now, what variables are relevant to this?
Right.
Let's say somebody walks into your store. if he's wearing a sweater, is he more likely to buy a pressure cooker? It sounds like a silly question, right? But maybe that is true. And you cannot decide before you analyze the data whether this is true. Maybe there's some roundabout causality that people who are very cold tend to, use pressure cookers to cook. I don't know. And nobody knows. And you
Right.
cannot, you don't know what is a relevant feature. But what he is wearing, how he, whether he's cut his hair short, whether he has, whether he's carrying a dog,
Yeah.
three-night dog with him, who knows what is relevant. And
So
then
when you say relevant, are you implying correlation or causation again here?
you
You're trying to
don't
find
really
genuine
want to get into
correlation.
causation with big data because even with small data, establishing causation will be very difficult. So all you want to know is, given certain features, is he likely to buy, something? And then,
Yeah.
you may not want to restrict the set of things that he may want to buy. Just because he's coming wearing a raincoat and with a hurricane warning in place doesn't mean that he's going to buy flashlights and, cans of food and not pop tarts, or for that matter, towels. You just don't know. So then
Right.
you have to look at his patterns and then mine those patterns, and certain supervised learning methods may be useful. Certain unsupervised learning methods may also be useful. And
Right.
these learning are pattern learning. They may not be correlation in a strict sense. They may be simply associations, which are technically speaking not really correlation. But we can use the word correlation in a sort of non-technical way and say that, okay, this correlates with that. But then, and in some cases you may actually want to measure causation. There are situations where causation is important. That is to say, the direction of causality. Are people buying Pop Tarts because they're going to be stuck at home during a hurricane and they want junk food because they're nervous?
Mm-hmm.
Or is it that people who live in hurricane prone places are old people and they like sugar?
Yep.
I don't know. Nobody knows. And uh, some cases, causality may be an issue, and in understanding the system, and in some cases where you're trying to design a system rather than simply trying to sell something.
Right.
So there are certain variables, certain system design issues where the direction of causality is in fact important, and simple correlation is not going to tell you that. These are also big data problems. This is a very, very new area, and some work has already been done on it, and it's a very exciting area,
So
but it's very new.
I just wanted to understand one thing. I'm sorry to interrupt you there.
Yeah, go ahead.
Uh, so there is this big data that provides all the infrastructure. There is this Hadoop and all, which is the paradigm of computing. And then there is machine learning, which I have an intuition about what it does. So where does predictive analytics fit in here? Or is it just an overlap of things?
Predictive analytics is in many ways a subset of machine learning. One kind of machine learning is prediction learning. So in predictive analytics, what we are trying to learn is the model that maps inputs to outputs, where the set of inputs may be an unrestricted, a very large set, and the set of outputs may also be somewhat unrestricted. Nevertheless, it's a learning problem, and it's a map learning problem. That is an input-output map learning problem. Once you have learned the map, then you can predict. Some predictive learning problems are best thought of as a more basic regression or even a time series forecasting problem.
Okay.
Uh, those are typically not big data problems. Uh, most big data problems are in fact machine learning problems,
Okay.
and predictive analytics really is a subset of machine learning. And the infrastructure, the software, hardware infrastructure is being created. Hadoop is the default standard right now, but it's kind of starting to give way, and new things are coming in. Again, this is not an area that I actively follow, so I cannot tell you much more about this. But
Got it.
what I have
Yeah.
read suggests that Hadoop is kind of starting to become somewhat obsolete in terms of the latest use.
So what is new then?
Google is coming up with something, I believe. They have already put it out. There are certain startups which have put out some tools. Uh, all the big guys are working on stuff. Yahoo is working
Correct.
on stuff. IBM has a very active project that's working on stuff. All of this is all proprietary, and they haven't released. None of it is open source yet, I think. There may be some open source projects too, but I don't know.
Right, right. MapReduce started that way. Yeah.
Yeah, but MapReduce itself is supposed to be not quite state of the art anymore.
Right, right. I was saying it started that way as proprietary,
Yeah,
then
started that
Oh,
way,
yeah, yeah,
and
right,
then
right, right, right.
yeah, and then Yahoo took it on and made it kind of built on that and made it open source, and then made it
Right.
Hadoop, and then of course a lot of guys have been working on Hadoop because they say that Hadoop, like Devashi said, has deficiencies and inefficiencies and all kinds of stuff. So there's a lot of work going on. There's people have taken Hadoop and kind of made it kind of semi-proprietary again. But yeah, this is a very, very rapidly evolving area, so you do not know what is going to gain traction in the weeks and months ahead, and what new is going to come up. We will try and schedule, I think, with a couple more people who have been working in this area, a session on big data, predictive analytics, maybe within a month's time. So we can get into that a little more in detail. Right now, if there are no more questions, I'll quickly try and get on to some of the examples and applications that is the last part of this, and then we could discuss that, and that may illustrate some of the some how businesses are beginning to use it, and so on. So if I could just kick off that session, and
Yes, right.
yeah, I just have I'll just bring up a slide for that. Yeah, it is. Okay, so I'll just quickly go over this. I mean, I think some of it I have already hinted at or talked about. One of the applications which Vikash, could be interesting to you and organizations like yours is there's intelligible text generation using a variety of sources like news headlines or sports statistics, financial reports, sales, even images, etc. And there was a very interesting article, for example, sometime back in the New York Times, where they gave absolute, about 8 or 10 pieces of text, you know, proper English language text, which included poetry, for example. There are poetry apps which are generating kind of poetry out of when you feed in parameters and so on. They're generating poetry, and nice poetry, if I may put it that way. But so they were like brief news contents or news items which are being written by algorithms. There are usages like for example, financial reports which are being generated from a lot of data about financial data, financial reports. So this is one area that is happening. I came across a usage where I think the name was withheld, but this again is in the US. Of course, I mean, most of these case studies would be in the US because that's where most of the work is going on. Um, this was something like what an air traffic controller does for aircrafts and airports and so on. So this was like an air traffic controller for hospitals and healthcare institutions in that region. And what they were doing was, this was again a big data kind of case study where uh, ultimately they were able to, the objectives were to improve patient care and boost operational efficiency, by helping staff make the better choices regarding allocation of existing resources. Now, resources in a whole lot of areas: human resources, other resources, devices, nursing resources, beds, rooms available, a whole host of resources. But they were able to make, increase operational efficiency by using this very optimally and efficiently. Again, a big data analysis. There's a case study of UPS, for example, which I picked up, where they've been using geoloco data from their vehicles, which are GPS readings, sensor readings inside vehicles, and so on, to predict things like engine trouble, for example. And again, this is a big data analytics case study. They have been optimizing itineraries of those vehicles. They have been routes of those vehicles. And one statistics that I came across is that in 1 year alone, in 2011, they shaved off about 30 million miles of their routes and saved about 3 million gallons of fuel, and of course lots and lots of time, of their people, by doing all this analysis. So which was a tremendous gain for UPS. Uh, Social media networks, for example, the ones by Google or Facebook or Twitter or Pinterest, they are using AI on all the unstructured data that they have to really improve personalization. And they're working on areas like new marketing areas like audience clustering, very sophisticated brand sentiment analysis, and of course predictive marketing. So these are some of the areas that they've been working on. I will quickly kind of touch on maybe one other area where many of these technologies that we've been talking about is being used, and which is the area of smart nations. And okay, this is the smart nation terminology is typically something which is being used by Singapore, because Singapore itself is a city. It's an island city, and so therefore a smart city there is equivalent to a smart nation. A lot of these elements are already happening and in place, but if you look at an objective or a vision statement as laid out by the Singapore government, which is typically driving this initiative, they say that they want to build a very pervasive infocom platform, which will support businesses and which will support the government bodies and administrative bodies as well as individuals. And it will give them the ability to harness capabilities and resources across geographies, so globally. It will facilitate export of ideas and products and services, and hopefully, I mean, as a adjunct of this, it will supposedly fuel creativity and innovation. So that's a very, that's quite a mouthful, I know, but that's the vision statement, or a compact vision statement of what the government has put out. But getting down to smaller modules of what it will do. SMEs, for example, SMEs, as you may know, is the acronym for small and medium enterprises. So it talks about offering a host of infocom solutions to these SMEs, and as well as SMEs using the whole network or the platform can adopt various SaaS or software as a service solutions. Then there's e-government and mobile government, which of course it's a slew of cross-agency content and services which will become applicable to individuals as well as institutions. Finance, launch of NFC payments particularly. There's a whole lot of things which are already available in finance, but they're talking about launch of near-field communication technology and NFC payments island-wide. And they are talking of ramping this up in about 2 years' time to about 30,000 payment points across the city or across Singapore. Major applications in the areas of logistics, supply chain, traffic management systems. The first two I might mention. Singapore is a major logistics hub. It's arguably the busiest container port in the world. And it's a major airport air traffic hub for Southeast Asia or across Asia Pacific for that matter. So therefore, logistics and supply chain there, and of course, this is traffic management is very important. So, the first two I might mention. Singapore is a major logistics hub. It's arguably the busiest container port in the world, and it's a major airport air traffic hub for Southeast Asia or across Asia Pacific for that matter. So therefore, logistics and supply chain there, and of course, this is traffic management is within the city or within the island. Um, Applications in the areas of healthcare, hospitality, tourism, retail. They're talking about enhancing m-commerce activities, a host of services which they can offer to the users and customers. And for individuals, some of the areas would be like healthcare. They're talking about telehealth, for all its residents and citizens. And they're talking about, starting off what they call future schools, very diverse learning environments using all this infrastructure. And there some of the things. See, the infrastructure is already in place. There's a fiber optic network in place. The broadband network is getting fairly pervasive across Singapore. The last statistics that I had was that high-speed networks would eventually, in I think the next 6 months' time, would be available to about 86 or 90% of the population. And so all that is in place. The telecom infrastructure, the government is for reasons of privacy, security, integrity, reliability, and so on, they're building their own telecom infrastructure rather than relying on the telecom service providers. There are 3 or 4 major telecom service providers, but the government is kind of building its own infrastructure for this. So that's some of the stuff about what they call a smart nation, or what typically is called a smart city, and some of the stuff which is happening in Singapore in this area. And I'd stop there, and in terms of applications and smart city concepts and usages and so on, request some of you to kind of pitch in and contribute what you may want to.
Raja, if I may, one of the fastest growing and best known uses of big data is in the field of sports. Nate Silver, who is perhaps the best known data scientist in the world because of his book and his notoriety during the US election, started out as a baseball statistician.
Right, I've read his book.
You read his book, right? Signal and the Noise.
Yeah.
And one of the best introductions to the analytics, analytics, is the movie Moneyball, starring Brad Pitt, which is about the application of big data methods to baseball. In fact, sports analytics is one of the biggest application areas of big data. Baseball was the first one because, like cricket, it is a very statistics-driven sport. But now it is coming in a big way in all major sports. For instance, a large number of football clubs have now video of all their games with isolated feeds on specific players, some of them on all their players. So you have 11 separate feeds at all times, and perhaps 22 including the opposition. And this data is then, this is video, and this is analyzed and you can imagine the number of dimensions of analysis that it will require, because you're talking about visual video data, and this is being used. Same in basketball. All of the action is being recorded and analyzed at great detail, and it is a very big application area, and I don't know how much of it is used in cricket. I think there is some of it in even cricket, but baseball, basketball, football, American football are all being heavily analyzed, and it's a major application area of big data. And of course, it's very big business.
All right. Okay, Subhamoy, would you like to pitch in with some more details about some of the applications of some of these technologies that we've been talking about or discussing?
Yeah, I mean, one of the big areas that I see is finance. because finance as a domain generates a lot of data about customer, and also there is a lot of predictive element in that. So Debashish briefly mentioned about that. Being in a finance company, we see that there are multiple variables. I mean, you can't define that which variable will cause to select a particular product for a customer, but there is a lot of scope in analyzing that. So, for example, if you try to pinpoint which is the best customer for you, and then you try to figure out that which monsoon they will get a product from you, and which product is best fit for you, so that's a huge problem. And there will be variables like macroeconomic situations, there will be variables like what assets is he owning, what is his life cycle. So this is a big area indeed. And defining a model is not easy, though we try to define a model at some point of time, but most of the time those models are based on the historical data. So it's more of seeing whether there is a correlation between stock market and adoption of a new loan, but that may not be the right approach possibly.
All right. Yeah.
I just
Thanks,
wanted
Umay.
to add one thing. So I work at Thomson Reuters, and as Raja mentioned earlier, we have a very heavy usage of textual analysis. And one of the awesome tools that the research department at Thomson Reuters developed is a summarization tool. It mines all the text of all the news and gigabytes and terabytes of data that comes in, and it summarizes the content. It's used at various levels. One being at the content that is being brought in terms of news from around the world. That is one way of summarizing into small articles. And the other is you take a big book and you want to, an output is a small summary of 3 or 4 paragraphs, very well summarizing what the book is talking about. So that's one area where Thomson Reuters invested a lot, and I found that pretty useful and pretty impactful, just because the aspect of the amount of time saving that is there with summarization and the accuracy around that, because you could just read a one pager and understand whether you want to read the book or you want to read the news in more detail. That's a very substantial amount of time savings. So that is one area. And the other area was related to the topics that we have been talking about, was Reuters at one point in the recent past had a very high competition from Twitter. So even though Reuters is into the traditional news gathering kind of a setup, the online disruptive technology of Twitter has in fact reduced the revenues of Reuters in terms of news. So what Reuters did was, instead of competing with Twitter, they're trying to reduce the noise around what is successful right now. So the news on Twitter is, there is noise around that. There is there is authenticity around it. So Reuters is currently investing in developing algorithms where it mines the data on the Twitter, and it almost kind of provides the authenticity of a certain news on Twitter. Almost like a PageRank, something similar to it, where it does some real-time analytics behind the scenes and tells you a few minutes after the publishing of the news how authentic and how believable the news is. Just wanted to share these two insights with you.
Oh, thanks. In fact, I was about to ask you, because whether, for example, Reuters is using some of these apps and these AI apps to generate intelligible either textual content for some news items, or even maybe certain financial reports. Is that already beginning to happen with Reuters?
Um, um, I'm not aware of it. It might be happening, but the fields that I'm aware of is the textual analysis. As I said, the summarization of it is huge in Thomson Reuters. And whether the same technology can be used for financial reports, I'm sure it could. I just have not seen it. So that's the so I can't put my finger on it. But yeah, I believe the technology exists to summarize, and the same thing can be used to financial reports.
I believe that Reuters has a tool now where they provide a tag to stories uh, that are, this is all economic and financial stories I'm talking about, and where they classify the stories with regard to their view about specific economic events. Somebody sent me a link to Reuters tool, and this has been used in trading. In you analyze stories, and currency traders are using it to form views about the macroeconomic climate on certain economic issues.
I see. Got it.
Great. I like I was saying, I think we should plan to have a separate session just on big data analytics and predictive analytics. Maybe fairly soon, and do watch out for that. I think in certain regions, for example, we were quite late. For example, if you take Singapore, it's past midnight, and because we were trying to juggle the time so that we could take in participants and viewers in North America, in the US, and in India, and maybe certain parts of Southeast Asia. So I do not see any other viewer questions as of now that we need to answer. So if we have nothing else, we will try and close and round off this session today here. And thank you all for your participation and for your insights and inputs. I think it's been a great session. It's been a great discussion that we've had, and we will continue doing that. So I hope at least this has been interesting enough and insightful enough. We would invite you to join for future sessions, and we will send out the once we schedule them and we have the details ready, we'll send out the invites. So do keep coming in and do keep participating. And all right, so thank you all
Raja,
very much.
Raja, if I may, I have one suggestion.
Sure, tell me.
In the past, I've seen that depending on what the goal of these sessions is, it was super helpful if we could take a use case, a practical use case, and run it from end to end using some methodology like whatever the topic is, the predictive analytics versus big data or Hadoop. If we take one use case, you talked about the correlation between the hurricanes and the pop tarts, and take it end to end, I think that really gives, even though however simplistic it is, that really will be more effective depending on what the goal of the session is.
Sure. We will try and see if for the next session we'll try and get people who have actually kind of worked in some of these areas, and maybe they can share some typical case studies that they have. We'll check that with them before, and get in people who have done work here. So hopefully it'll be an insightful session as well. So thank you all very much for joining in.
One thing, just
Sure.
about the mechanics of the thing. You saw that I came in late, and that's because I wasn't able to figure out how to join the session. And I think Mr. S.N. Roy, he had the same problem. He had a message out saying, "How do I join?" So there was some confusion on that issue, and I guess we need to fix that. Maybe some people
Yeah, I had
didn't come in
I
because
had
they couldn't
yeah
find the
we
link to join.
yeah see the link is actually given right together with the invite. If you see the details in the invite, you can go and see it later.
Yeah, I did.
The
I
link.
clicked on that, but it didn't work. I don't know what went wrong. Anyway, that's just a mechanics issue.
Yeah. So but of course that's a predetermined URL, and it only gets active once we go live on air. So if you do it a little earlier, it does not happen. However, what I did was using that link. For people who had confirmed to you, to SN Roy and Vikash and Subhamoy and several others, including Eli, I sent out an invite just to make sure about 5 or 10 minutes before we actually went on air. And in fact, initially there were three of us, Subhamoy, me, and Vikash. We were chatting for a while. We were waiting for people to hop in. And then, once we were past the time, we said, well, we will not delay the session. We will start on. So I think it's a basically an issue of getting familiar with how Hangouts on Air work, and I'm sure it should get easier with subsequent sessions.
Okay.
So yeah, so we'll round this off here, and thank you all very much for your participation, and hope to see you again for future sessions. Take care. Bye.
Thanks
All right.
for organizing it. Bye.
Thank you. Bye.